full node. That's how we do it.
Okay, I'm recording.
Can you guys like put a sign like in the treehouse? Can you guys like take over the treehouse?
Oh, we're not taking over the treehouse. We're taking over the whole thing.
Oh, okay.
Yeah,
You should put up a flag.
Yeah. Tomorrow you will find all keys are changed.
Again, they do that, like, even without you, they do that from time to time, so.
I mean, you are staying because you're part of the cartel, obviously. But the rest, I'm sorry, I'm just gonna like ban them.
Alex. Alex is here. If I pronounce that. Yeah.
So for clarity, like the purpose of the call is basically, I think Alex and Merrick called us here, right? And it's to do with standards around the smart contract and delegated execution. Is that right?
Yes, I think we should start with very basic stuff, which is the format of the declaration of the functions.
Yeah,
because well, if it's not consistent, then I guess there won't be any interoperability. And of course, it's just the beginning, but you know, we have to start with something.
So hey everyone, I just like to say hello, and before we go into the format of the functions, I would just like to clarify the call. I think so. Next week we'll have like Web3, and some of you might be there, some of you will not. And the week after that will be the Prague Blockchain Week with tons of events, and I hope that most of you will be there. And I hope that we get people to talk together, sit on a table, and try to come up with standards and show our work so that everyone can share what they've been doing. So what I would like this call to be would be sort of a preparation for those meetings, right? Where we sort of already discuss, we show a little bit what we need to discuss in those meetings, what sort of conclusion we want to reach there, so we can sort of have an idea what will be the topics that we will end up discussing and what I hope to be like the where everything gets together will be at DevCon itself on the meta transactions panel. So that's why I want to sort of have everyone together so that we can sort of discuss most stuff. And I think one of the most important things is that Marek has worked a lot on the implementation of universal against, and he has a lot of feedback, and he would like to share with us what he learned from the beginning. That was like trying to do the ERC-1077 like proposal to what he has learned from in practice what we need. So sorry, Marek, take it on.
Sure. So I thought I have updated. I thought I have updated GitHub, but I see it's still the old version. So I propose I share my screen, and I'll just start with kind of most recent version of what we talk about. That could be 1077. And then we can just go through it. Do we have is there a share? Yeah, I think there it is. Sure. Good. Can everyone see my screen?
Good.
Okay. So I think the first thing to discuss is execute signed, and feel free to like interrupt and say, yeah, this doesn't make sense, or there's something missing. If you think that's the case. I can also send a link to GitHub later, so you can go through it yourself. So the general idea is pretty straightforward. We have execute sign method. I think the name is something that can be also discussed, but it's I guess secondary. We have two value data, three fields that basically defines who we want to send transaction to, value of the transactions, and the data. I don't think there is anything to discuss here. Is there anyone who disagrees?
It depends a little bit. What is operation type? Like just
Yeah, we're getting it. I'm starting very slowly.
I'm just asking because, like, for us, like in our case with the safe, right? Like, I think also in the ERP-1077 they say that, like, for us, one of the base types for internal transaction or meta transaction is also if it's a call, create, or delegate. And I was just asking if that is a type because. Okay.
Well, actually, the operation type is taken directly from Gnosis Safe, the naming, the everything. So it's here, right?
Okay. Yeah.
Good. The nouns. So we think, and again, anyone who thinks otherwise, let us know. We think there should be a nouns, and which would work pretty much in a very similar way as a nouns on the chain. And what it would do is you would only be able to execute methods if nouns is exactly one you can only execute given nouns once, and you cannot leave gaps, right? So if the last nouns was 7, then the next is 8, and that also can mean that there are some that also would solve any front-running issues. There would be only one transaction that is able to, if there are multiple competing transactions, then there is only one that can succeed. Again, it's pretty straightforward, just to make sure. Is there anyone who would like to argue or agree or disagree? Well, I think we're good. And then there is a free following is gas price, gas limit, and gas token. This is related to refund function, and basically the contract would refund the amount of money. Well, the gas limit would be the gas use will be calculated, and as long as it's smaller than gas limit, then it's multiplied by gas price, and that's the amount to be returned in given token. Where gas token is the address of token, can be 0, then it's Ethereum. I think it's pretty standard across Gnosis, status, and other things I've seen.
I've never understood why the gas limit was there, but I'm sure, I mean, you guys are smarter and you've already gone through this, but is there a quick, like, too long didn't read that could explain why the gas limit is there?
So I know why we have it in the safe, but in the safe it's a little bit different than other implementations in the sense of when basically what we do, right, we wrap the meta transaction or we wrap the transaction and then do the user transaction or whatever you want to call it. But in the case of the safe, this user transaction can fail and the refund will still be paid. Mm-hmm. And in this case, you have to make sure that just by sending too little gas as a relayer, because you could do that, the user transaction might fail. So we have a gas limit to make sure that the relayer sends, like, it's basically the least amount the relayer has to send with the internal transaction or the user transaction. That's what we use the gas limit for, to ensure that the relayer cannot somehow forcibly makes the user transaction fail, still getting paid on our side.
Also, my understanding here is that we are trying to replicate a little bit like the limit on the Ethereum transaction, and the idea here is that there should be a limit on how much tokens the user will pay on that, right? So there might be a way in which the relayer could abuse that and force the user to spend a lot more tokens than they expected, or even like if the user doesn't know exactly how much the transaction will cost, because they don't know how like there might be an error on the transaction and the transaction might cost a lot more longer. We don't want the user to expect the transaction to cost $10 and end up costing $100, right? And I think adding the gas. So the gas limit is sort of upper limit on how much the transaction can cost to the user.
Yes, we can do initial check. We can estimate the cost of transaction before running it. This is of course not, let's say, definitive because of the front running and the possibility of substantial change in the state of the blockchain in between the estimation and actual propagation. But that's like a, let's say, preliminary check that we can do. We can assume in many conditions that would be actually working and secure the user against accidentally doing something that he didn't want to do. Any question, comments about this part?
Yes. For guest token, is it possible to use Ether or it just ERC?
Yes. If it's 0.00000, that we assume it's Ether.
Okay. Okay. And what do you think about the ERC-777? Because I assume this is only for ERC-20 or Ether. And do you think about something for ERC-777?
777.
Yes.
Which is?
It's like the new type of ERC-20.
But ERC-777 has all the same methods also as an ERC-20 token, right? So, no, they don't. That was another. There are too many token standards right now. Sorry.
Well, as far as we know, I don't know in particular about ERC-777, but it seems to me there is no any reasonable proposal for alternative to ERC-20 as of today that has been agreed to be secured. I'm not sure if anyone disagrees, but there was a bunch of people.
And also, like, this standard not necessarily is about the underlying standard that it executes, right? So you could, in theory, build your own contract with, like, your contract can stick to the 1077 standard, and then try to do multiple, like, it can attempt to do a ERC-20 call, or it can check if the token supports 777 and then try to do a 777 type of transfer call. So you can support other types of transfer tokens, but we encourage you to try to use the most common denominator.
Yes,
and I would suppose that would be ERC-20.
Yeah, for sure. I agree.
But I actually think it's a good practice for you to try to attempt to, because I think 7.7 has they have a way in which you can check if your token supports 7.7, right? So you can check if it supports 7.77, and then if it doesn't, then you fall back to a 10.20 standard.
Okay.
Shall we move to operation type then?
Sure. Yes, I have no further question.
So operation type, as mentioned, is taken from knowledge state implementation. It distinguishes three types of operation: call, standard operation, delegate call, which can be used to implement modules, and create, that is used for creating smart contracts. Well, I think it's pretty straightforward, but it's kind of first a little bit more tricky field. So I wonder if anyone have any opinions and comments about it. No, Richard.
So I think it's straightforward, but for me the point is always right. Like, it is potentially something that is very, very special for, like, which is super useful for us as a wallet, and there are probably some identity contracts. But I think it's not worth it discussing right now that it's really special, because there are a lot of really special things, and I'm not sure yet what is the best way to handle really special. That's I don't know.
So I think that's sort of why the extra hash exists, right? So the idea of the extra hash is that it's always, and of course I'm open to hearing better implementations of that. The idea has been that you always put extra hash as no, but you can add it as something else. So let's say that you don't use operation type, but you use, or maybe you can even take operation type out of it. You use operation type and you use something else, right? You use another thing. And what you can do is that you can, for uncompatible versions of or versions of the standard in the future that you use extra things, the way to do it in backwards compatible way is just to add them to the extra hash. So incompatible versions will just ignore that. So I think that's why, like, I agree that operation type might be a good idea here, and we may find other ways in which we can improve that, but we can add them to the extra hash and make it like backwards compatible with future versions. So that's why we have this. And if we think that operation type is not even like popular enough, we can remove that from the standard and make it so that other people will add operation type. Like you can add operation type in your thing, and for others that don't want to support operation type, they can just add the same operation type to the extra hash, and the hash will be the same for all. Does it make sense?
Yeah, I'd love to see the extra hash actually just be a bytes, so it's like kind of super extensible and we can put as much information in as we want there. And then a lot of these things like the operation type or the gas limit that may not be like absolutely necessary for the delegated execution, you could pack into just like a meta or an extra or some kind of byte array that can be of any size.
I actually think that's a good idea. We could put both gas limit and operation type inside the bytes extra data thing. I think that's actually a good idea. What do you think about it, Mark?
Well, I'm thinking out loud. I think operation type might be the last one that we want to left out. I'm not sure. Well, I think Richard, I'm hoping you get more valuable input on this one.
I would have to play around with that. So for us, it makes it just a lot more complex, and it's already complex enough, our contract in certain sense. So that's, yeah, I don't know. It's, for me, it's still a little bit like, because we have other use cases, like, I don't know, this is a super general interface rise with two value data. That's, I think we need to get this straight in the beginning. But yeah, there are a lot of questions even after the interface. So I think for now, we should just get one version going, and then we can still think about what do we want to move to optional or what do we want to get added.
And I default to Richard on this. I think that he has a much more complex setup than I do. But we definitely do need some extra data. Like, for instance, for subscriptions, we have to have, like, you know, the recurring period. So there's a lot more kind of our extra, at least the piece, like, we can leave operation type in there, we can leave gas limit in there. The one piece that I'd really like to see is that extra hash be more like an extra data and have it be a bytes array. So then with subscriptions or other stuff where I have lots of things I'd like to add in there, I'd like that to be more dynamic.
Does everyone agree?
Yeah, so since we are all discussing like gas limit but not gas token, I would move that we should switch those two around. So we have gas price and gas token, and then gas limit operation type and extra data. So that
I agree.
Like, the three of those could be included in all extra data if you wanted.
Yeah, it's weird to have the gas limit kind of packaged up with those other two. For a new person coming in, they kind of think that they're kind of related, but I don't think they're totally related.
Okay, let me then just check out quickly the other branch. And so that we kind of end up having something that we all see. Okay, I will increase the font size. So what you're saying is we have something like this, bytes extra data. Is that correct? Can you see my screen?
Yeah.
And also you should put gas token before gas limit, because it's something that gas limit, not everyone might want to use it. So we are sort of putting them in order of sort of importance, right? In a way.
Okay, what about operation type? Is that something still before extra data or already in the part of extra data?
I think we can leave that. That's my opinion, but we can think about that later.
And Richard, you too, you think operation type should be there?
But so for us, it's essential, right? It's like one of our core features that we have. So, but for us, it also belongs a little bit closer to two value data in our case. Like we put it there. But yeah, in general, I think I'm still not 100% sure what the best way is to handle all the extra data without introducing too much assembly in the contract. That's for me a little bit, because if you put generic data in the extra data, it's like you have to kind of get it out of the bytes. Which
but sort of, I think what we are saying here is extra data. Extra data is also a way for for backwards compatibility and for increased compatibility between contracts, right? Because you can have, because if you hash all those things together, right? It doesn't really matter if you don't use gas limit, if you don't add anything on, if you leave gas limit blank, if you leave operation type blank, and you put all of that into extra data, it sort of creates the same hash, right? So the idea here is that we are just putting them in our sort of order of importance, and giving extra data is not only for you to pass new data that you want, but it's also
that highly depends on how you generate the hash. So for example, in ERC-1077, they would not generate the same hash because you probably would have a different struct. And that is, except if you, like, that's the weird thing, or we would have to come up with the hashes of hashes, right? But that's a little bit different thing, because there you have, like if you use the simple one like you do, which is, I think, it's just like putting everything in a bytes and then hashing it to have the hash, right? Mm-hmm. Then that works. But I think for like if you use 712, you have to kind of define what is the structure of the data. And as soon as you do that, it becomes really hard to be backwards compatible anyways, because this extra bytes, how do you put that into a struct so that it's backwards compatible with the future?
One additional challenge I see with extra data is how do we interpret the extra data, right? Because let's say one relayer or one whatever else, one service uses this extra data in following way, and the other one is using this extra data in some other way. So
that's what I assume, like with the subscription, you need to check to see if the meta transaction is valid, right? So you kind of hit the can execute, and then it runs that extra data stuff through some kind of function to figure out if it's valid or not, and then just returns true or false. As long as the contract performs the correct actions, they should be able to do very flexible things with that extra data.
So we should have some kind of header for extra data that defines what we have in the extra data? Something like that?
For me, it's this interface. I think we will always run back into this, like, like me making it backwards compatible because we want in the future maybe to add something makes it really hard. Like if we think already now about backwards compatibility. But for me, like when I was thinking in the last weeks about it, I was always like, for me, actually, it should not, like for me, if I'm a relayer, actually it doesn't matter if it's two-value data. Maybe it's a function call that actually doesn't have two-value data. It's just like you really have just parameters for, I don't know, you want to make a move in a game, right? You want to make a move parameters plus the additional ones for the payment, right? So for me as a relayer, the only thing is I simulate the transaction, and then I want to see, did I get my money or not, right? And for like, I think there are two different approaches for us to go, right? Either we define an interface and then somehow have like a list of contracts that implements that interface and that we trust, because we need to trust all the contracts, which for me is super annoying to trust all the contracts as a relayer, because each time there's a new contract, we first have to, I don't know, add it to the TCR or add it to some registry, and it's weird a little bit. And the other thing would be if, like, we have this, at least in the issues, right, there is this more like if we really write kind of custom nodes for us or custom behavior. I don't know, like adding this feature that you have an RPC call where you can basically give a transaction and tell me what is my balance afterwards and what was it before. So basically, what did I gain from this one? It's super simple. Like I have a gas version, a Go Ethereum version where I can do that. Like for Rinkeby, I can specify any data. It's just I'm not sure which way is really better, because like with this whole simulate the transaction before to get your payment. I think there, when you look at the account abstraction EIPs for the normal accounts, you see they have like this one point where they say in the first 200,000 gas, it must be able to, like you need to be able to figure out if you can make the payment or not of this transaction, because the problem is, if you first need to run the whole transaction to figure out if you get paid, it's really easy to go do a DDoS attack against you, because the user doesn't like to just figure out if you get paid. You need to run the whole thing at least once. And I think but again, these are, I think, issues that also maybe don't need to be solved right now. but these are different approaches. And thinking about the different approaches, I think it's not super important right now what we put in the extra data. I think we should first get a version out there that might even be without extra data, just to get something. Like adding afterwards new bytes is cool, and it's good to think about it right now. But I think for the first POC, it might be interesting to have a simpler version, which is also it's unrelated to 1077. I think for 1077, it makes sense to think about it. But for our implementation, when we decide on a signature with a trusted contract database or whatever, I think it might make sense to maybe have a compact interface.
So here's, I want to take a step back. So sorry, go Marek, go there.
Thank you.
First.
No, I mean, why would we want to, because you mentioned like if we want to move something in the game or like different kind of, that should go to the data, not to metadata, right? Or extra data. But also, if we want to implement different features, why not just make it delegate call operation type and put all the meta information data, right? Because extra data should, first thing to notice is extra data should not relate to content of execution. It should only relate to the way you do it, to the execution itself, right? Like operation type, I would argue, is very, I don't know, primary operation, because it defines how you process things on Ethereum, like in very low level basic way. And there are perhaps different ways that we don't think, different things that are also important that we don't think about. But if we talk about, let's say, recurring payments, then maybe recurring payments is something we can do delegate call to some module that would enable future withdrawals from the contract, right? There is no need to implement it as an extra data, because it's not the essential execution of this particular signed message.
I think I sort of agree. I think that like if you want to do something like recurring payments, right? Would you want to do that in? Do you want to actually put that in that signature, or do you maybe want to go execute a contract that authorizes? So if I want to do something like recurring payments, maybe what I would do is I want to do like I have a DAI, I have a token, and I want to authorize a contract to use my token in a given way. And if I want to do that, then what I'm actually doing is not putting anything in extra data. What I'm actually doing is I'm calling my token contract maybe, and I'm doing an approve function where I'm approving a contract to allow it to take data out. So I'm doing everything just on the two value and data fields. I don't see how I'm using the extra data for that particular use case.
We did, sorry I cut out there, my internet was bad for a little bit, but we did use extra data just for the recurring amount. Like you need to know how many, like the number of seconds that it should recur, and that needs to be signed in the meta transaction. But it was really useful because we could sign that right in the transaction and send it off to the relayer network. And then you would just approve over on the ERC-20 standard side. And then it would just like set it and forget it. The thing would recur forever. So it was very powerful for token subscriptions and ETH grants. But I don't know if that fits in here. Just kind of throwing that.
Why do you need to do that on the extra data and not on the data? Because the extra data is sort of a message for the relayer, right? Not for the contract. So why?
I think we could have encoded it into the data, except for then when you want to do delegated execution subscriptions. So that would be like you want to actually execute like a certain call data on a certain recurring period. Then you need the recurring period to be outside of the call data, because it's the call data that's passed into your call function. But then you need to have something kind of controlling it or dictating how often that recurs. And so it just needed to be a secondary variable.
So my proposal, and again, it's not my original idea, but what I've seen in Gnosis Safe is that you have the modules, and let's say you have a library, and you do a delegate on library, and you use your identity storage to call another function, right? So you would have completely external function and perhaps different, let's say, piece of storage, piece of state of the contract that defines what you can do. And there could be, separate separate contract somewhere where that would be used to call recurring payments.
The good thing about having it in a signature, though, is it can happen off chain, right? You can set everything up without having to do any storage in the contract, which is pretty powerful to not have to pay for all that storage.
That's true. So taking a step back, so what we want to do with that is we are not trying to solve every single like of the problems. What we're trying actually to do is make sure that, let's say like I'm working with Universal Logins demo or with Marek. What I would like ideally is that whatever thing you do on Node Safe, it will be compatible with my demo of Universal Logins, right? So I can sign something on my demo, and then I can send it to Node Safe, and they will sign it, and it will all work on the layer. And the way we are doing things, and the way we wanted to do things like a subscription, I would imagine is that like in our version, and that's not in that standard, that's part of like the more general identity part, is that every key on our side would have a contract that would say which sort of authorization it has to do, right? And you could have one key that had the power, let's say, to always make calls to a given token up to n time, right? And that's how we were doing the subscription things. But then, of course, you need to sort of do some sort of contract storage, and it's not. It's something it's sort of on chain, right? Because you're doing like an amount of you're taking an amount of tokens per month, and like your authorization is stored on a contract. But then, so my opinion is that I would say like let's leave. So so let's make like extra data is something that you can use to do things in your contract and experiment. But like in our implementation, we would probably just ignore extra data. We would just take like extra data is something that other people are dealing with, and we accept extra data, but we are not doing anything on the contract itself about it. Just so that we want to be like compatible with other experiments.
Right. It should be super easy for you. Sorry, the internet cut out again and I missed a little bit of that. It should be super easy for you guys just to throw like a 0x0 in there, right? Like it's not that expensive for it to be like super extensible for us to do like a lot of other stuff in there.
Yeah, I agree.
So is that kind of what we're talking about? What do you see on the screen?
It looks great to me.
Yeah.
Good. Okay, so then the second, we discussed with Alex a lot, and there's a little different ways to like how do we different approval schemes, right? So let's say we have 2 out of 3, but then if it's a backup code or if it's a management key, then maybe it has different ways, right? How do we interpret these message signatures that can vary a lot? And we don't think it's a good idea to include in ERC-1077 any of that. That should only focus on execution. And what we propose is we have can execute method, which basically delegates all the fields, and then somewhere else in some other standard is defined. Is it called multi-sig? Go ahead.
So what we were having before is that we had something that was a public function called require signatures, right? Where you'd say it requires 2 signatures, and then you can check, oh, there are 2 signatures. Those are part of this identity. They are management. Because we were basically importing a lot from the ERC-725 identity, and the identity has like a few sets of roles. You have management, you have action, and it's like a 1 or a 2, and you have 2 signatures, right? And our first idea is that we will just check, are those like, it needs 2 signatures and it needs 2 managers, right? But then what we realize is that this is very specific to 725, and that's not necessarily what we want. So the idea is that instead of having to check how many signatures and what's the admin, all you need to do is just pass all the same information that you have on execute sign and ask if it's a can execute or not, and it will just return a true or false. So the idea is that the relayer just wants to check if that signal, if that message will be executable or not. It sends, and the contract just tells them if it's true or false, right? And it can internally, it can have an n amount of ways of doing that.
Exactly. It makes it very universal, where basically a relayer, once a relayer knows a contract is good and knows that the tokens are worth it, he just checks to see if he can, and then he executes if he can.
Exactly.
Any other comments, questions about connecting?
I have a question to connect. Why do we need an extra message for that, right? Why can I not just do a call to execute sign and looks if it fails?
Well, I would imagine that execute sign is calling can execute, and it's let's say it's an abstract method, in particular ERC-1077 implementation, and you only deliver from that and perhaps some kind of key holder implementation, and you say, okay, this is 2 out of 3 in a subclass. Do you see what I mean?
Hmm.
So it's not necessarily something that you need to, you can call it upfront as a, again, initial check, but the thing is that execute sign is calling can execute that can be implemented in subclass.
I think if you're a relayer, you can just try to do execute sign and fail, but I think it's, in my opinion, it's useful for you to know, is this failing because it's sort of asking the contract, because there could be other reasons that that call is failing, right? And one of the reasons is just that the contract is refusing to execute, or other reasons it could be the contract is able to execute it, but when it tries to call it, it fails. It's sort of 2 different things, right? You can try to execute it, but it's eventually gonna fail. It's different than I'm not even approving an execution. So I find that it might be useful to have that.
Does that make sense?
Yeah.
Yeah, that makes total sense.
Good. And I think we're almost there. So there is a last nouns. It's just together for the nouns, operation type as discussed. And I think there is also one more thing, the events, which basically have 3 arguments. Starting from the end, we have success, which pretty much defines if the execution of the call or other operation was success or not, the nouns of the operation. And also, we're proposing to have like, let's say, execution ID, which would be basically, in my latest thinking, it would be basically a hash of all the arguments, so that if there are two competing transactions with the same nouns, we can actually know which one was executed afterwards.
One thing I'd like to see in the event, what we're finding is as you execute something in a proxy contract that then goes and talks to some other service contract, that service contract, the message.sender is the proxy contract. So say it's like some like music service, right? It's going to look like the proxy contract uploaded that song. So what the front end has to do is go back to the proxy contract and then figure out who actually sent it so they could show the right from ID there. I would like to see in the executed sign some kind of like.
I think
awesome. Yeah, we cut you there.
But why not saying that the proxy contract? Why not saying the proxy contract is the identity of the user?
Yeah, sorry, Austin, we lost you there. I heard like you saying something like what we wanted to see is, and then we lost it.
I think Richard is also out.
No, I'm in.
Okay, you're just moving. Okay then. So just Austin. I didn't.
Motor was saying something.
Yeah, basically, if I understand what Austin said, is the message.sender function is a proxy contract when you're making the call to the relay contract. And what you want to do is to know the address who made the call to this proxy contract. And you cannot see it, so you want to put it in the event of the proxy contract. But then my question is, why not consider the proxy contract as the identity of the user for this call, for example?
Something like this.
But I don't get it. Like, isn't the identity the same contract that is sending these events? Isn't like the identity will always be like me? Right? It's a proxy contract that is publishing those events, right? So,
yes.
What is the identity showing? I'm not sure. I don't know if I understand.
This is what I have understood from Austin. So.
Okay, I mean, perhaps
but what if you have a proxy contract that
oh, I think he's coming back. Is he?
What if you have a proxy
represents
contract?
like all?
That is very bad. Can you type it, Griff?
So
It's synchronous, right?
I think what he's trying to say is there's some scenarios where you have a contract per user, like the identity contracts, and then there's other scenarios. So where I'm coming from is this ERC-1077, where you have the ability to do a meta transfer and pay, and each user only has a certain ERC-20 token, which means that the contract is a single contract that's executing for every user rather than one contract per user. So maybe there's just these different scenarios, and I don't know if we're handling all these scenarios.
Yeah, it makes sense. You're basically saying that not every meta transaction is executing for identity. It could be executing for a token, and I think you're correct.
mm-hmm.
Then maybe in that case, should we just add a generic like byte on the event so that anyone can publish whatever they want? Does it make sense?
Don't use bytes, right? Don't use bytes on events. That's they will get hashed, and then you don't have anything from it.
Okay, maybe bytes 32 then.
Yeah, like you need to use a non-dynamic type, else it will get hashed. So bytes 32 or address int, anything works, but no arrays, no bytes.
I'm just wondering because is it because the ERC-1077 is making an assumption that there is, let's say, identity, or there is a contract representing person on the blockchain. So that's a little bit different from just having a relayer contract that relays messages for different people, right?
No, I don't think that like it. I don't think it's part of that standard that you need to have a proxy. I think the point is you could have a token that accepts signed messages. You can have a token that accepts meta transactions, but I don't see that as a problem.
But then you would need to have one more argument here, right?
No, because actually look, I think that you need to have that. I think you're right. I think you actually need that address from, but
because you would need to know who was the person. Kind of
that's recovered. The from is recovered from
something. No,
actually, I think from is important there because it's a sort of a replay attack prevention, right? Otherwise, what I could do is if you don't have from, and if I have like one key that belongs in two identities, if I sign a message for one identity, you could just use that message in other identities, right, or something like that.
sure.
So maybe from is important.
That's in the hash. We need to have it in the hash for the replay attack, right? Which is like, here we have a calculating hash, and we have from, and basically from is always this, right?
I see.
I think it's somewhere here. No, maybe. Yeah. So when we want to that, it's always this. But now I think if we want to state the intention, who is the person sending something to someone, then we need to have an information. Okay, here is the guy sending someone.
Completely agree.
Or we can expect the key of, let's say, executor, right? Is the from, right? Then we can take it from signature. Which would be
I always thought the from just came from the signature, but you could always add the from in there just to make sure the signature was right and no one did anything on accident, right? If they changed something little, the from would be someone else, and that could be weird, where if they sign the from as part of the signature, then it's kind of It's just an extra security measure.
Sort of, because if I'm using a proxy contract with an identity and I have like 3 keys that are signing in behalf of that identity, the from is the identity, right? The from is not from those keys.
That's right. Yeah. Okay. I was thinking of it as a single signer, but you're totally right.
So there would be 2 cases, right? Go ahead, Alex.
So what I'm feeling is that maybe we need to add the from there just for compatibility purposes, because for some cases you will be using like the signatures, for other cases you won't be using the signatures. So it might be useful, or that's what I'm trying to understand, right? Like in our case, we wouldn't be using the from, but it might be useful for some others. So that's a lot bias. Always.
Always. Okay.
Yeah, I need to think about like the use cases.
For identity.
Because like it's always this for identity, and if it's a case of a multi-token where you're sending for a bunch of people, then it's always the message signer, right? So again, I'm not sure if it's useful or not then, because it's either the identity or the message signer. So I'm confused. I think I would have to think about it.
Yeah, maybe we don't need from in the execute signed. We just need to, in the event, we probably need to fire the fact that a certain thing signed it, and then you could also see the contract address, which would be the identity proxy. Up to you guys.
Okay, I think I agree there.
Okay, I added it here. Good. I would like to stop for a second in the execution ID. Coming back to the case when there are 2 different transactions that are competing with the same nouns, I think the reasonable thing to do to ID would be simply the hash. Could be very well the same hash that we calculate before having signature. So basically the hash of all the different fields. Does that make sense?
Yeah, I think I agree.
I think original proposal was to have just some subset of the fields, but then we could probably find cases for every single field whether it makes sense to propagate transaction again. And then,
yeah, I think we just need to copy and paste the stuff from execute signed up to can't execute.
Yes, so that's one thing. But the other thing, the execute signed returns byte 32, which is basically execution ID, and it is also emitted in execution signed event, right? That's what I'm proposing. Does that make sense for you?
Yeah. Okay. So we have 2 minutes. We have 10 minutes now, and I have like we can either keep discussing this, or I would propose that we discuss either one of those 2 things. I think that Austin has mentioned a little bit of how he's using extra data and without assembly, and he mentioned that on the group. We could talk about that. I haven't understood exactly. I would love to hear more about that if his internet is working. Another thing we could discuss is that it's not exactly part of that standard, but it's important. It's like a standard for you to request to add a new key to a identity contract, right? And that might be a larger discussion of identity and proxy contracts, or not. So what do you say? What would you prefer to hear about in this 10 minutes? Austin, how is your internet going?
It's so. So I just put it on my Twitter. Basically, you just do a call to the your own function. You just do kind of like in assembly, you do a call, and it calls the function in your own function. And as long as the byte array has the function bytes first and then the arguments, it will cut it up for you. It just saves you a lot on assembly. I'll paste in the link, but basically that's all kind of self-explanatory. And I put a repo and I did a screencast, so I don't want to take up any extra time. I'll just paste a link so you guys have it.
Mm-hmm.
Okay.
It has some additional gas cost. You have to be aware because it's basically doing like another transaction inside your transaction, kind of.
Yes.
So
for
also
sure.
the message.sender changes. It's like, which is actually a good thing because it changes from the relayer to your contract. But so you just have to be aware of the side effects.
I mean, isn't how the proxy contract works that the proxy contract simply calls itself in order to make calls to itself? Or are
proxy contract? The proxy contract is basically delegating. Like if you talk about this delegate proxy, right? It doesn't have really code. It just pulls the code from another contract and then executes it within its own storage.
Okay.
Good.
Yeah, but because the idea would be that if you want to, like, you want the contract to add like a new key, let's say, then what you do is that you ask the contract to call itself, calling the function add new key.
Yeah. So for us, I think like in this case, what you described, right, this add key, or for the Gnosis safe add owner or something would be in the data, right? Like it's a bytes data, and the 2 would be the safe or identity contract itself again, and then it would do, like there is no need for an extra data in this case for like what you said, right? I think for, yeah, that's why I was asking a little bit how this extra data works, but
okay, I'm gonna watch the Austin videos then, and then we'll.
Shall we then just quickly on the key issue? So if we would like to have interoperability between the relayers, then we should be able to do from one relayer would call an add key method in the contract that perhaps was created by another relayer. So one interesting question would be, how do we standardize, how do we structure adding keys? And the obvious challenge is different implementation can have different metadata regarding the keys, right?
So Mary, can you put on your screen how we are doing currently in your code so that we can sort of compare? And I know that Gnosis is using the concept of add owner instead of add key, and I wonder if that's just a name difference, or if you have a different like idea of that, because in our idea, like not all keys are owners. You could be adding a key, but it would be limited in what it could do, so it couldn't be considered like an owner. That's why we were doing an add key thing.
Yes.
Yeah, I think there is a difference, right? Like for us, basically the owners are the ones that can be used to execute transactions, any kind of transaction. If you want to have a more fine granular management of what a certain key should be able to do, you would use, in our case, modules, which are basically contracts that are allowed to use the funds and the execution logic of the safe, but they can implement their completely own logic, how they verify if somebody is allowed to execute it, which is, this one is like, makes it really extendable, but if you add the wrong module, that's a security risk, but that's a different matter, right? Like, and that would also be the thing, right? For us, we have a module which we envision that it's only for recovery. Like you have 2 owners, normally you have the 2 owners that execute everything, but if you lose a key, you would have a module that has some predefined logic, how you can recover access, like replace an owner or something. And that's there also, again, that probably would be able to execute the methods on that module via a relayer, because you don't want, I know there's this common approach that you have 5 friends, you give out keys to the 5 friends, you don't want that these 5 friends have to have ESA, right? They should be able to just do shit on the contract. And so that's, I think that is a different understanding a little, like I think you have this logic more all into one contract, while we said we have only this execution logic for the owners, for all owners in the contract, and everything else is modules around this contract.
Okay,
makes sense.
I would, okay, sure, talk, and then I would like to present something very quickly. So if you could like stop sharing.
Well, just, I mean, we're currently using ERC-1077 implementation, which we find not so great after all, because it has very specific logic that is not necessarily super simple to implement and not necessarily bring a lot of value. But the point is, we have the key, we have some name, we have key, and then we have some metadata about the key. So the challenge is how do we standardize the metadata, which could be completely different for recovery with friends, completely different for standard keys, and so on and so forth, right? That's kind of what I'm thinking about, but in the same time, we do want to have this add key somehow standardized, so I can kind of, add device from different vendor to collaborate on one identity.
So Richard, it sounds to me that what we are trying to do with models is something that we are trying to do with what we called authorization contracts. And the idea that I was proposing is that when you add key, instead of having purpose and type, what we would have is an address and a byte. And the idea would be that that key would have an authorization, which would be a contract on an address, and then it would have like an extra byte. So it's like address and you need to add an address between the key and the byte. The idea being that whenever that contract would use something on that key, it would call that address and ask them, look, is that key authorized to do this action? And that address would come back with a true or false. So we are sort of, it's sort of that logic of models, but we are basically having a contract that is the terms of use of each key, basically.
Yeah.
But of course, that's a separate discussion. That's not necessarily a meta transaction thing, but it's more like how we are doing identities.
So Alex, kind of in the closing here, anything you want us to prepare specifically for DevCon? Like what would you like to see?
So who will here be on Web3 summits? I'll be there. I just want to know who I'm gonna hit. Hey, Boxer, good.
It doesn't look like a lot of people are going to be at Web3. I just talked to different people. Everyone's going to be at DevCon. Everyone will be. I recommend we host probably. I'm not sure. We're yet to see the schedule to come out for DevCon, but potentially we could have this private, kind of more private, kind of MetaCartel meeting on finalizing the draft beforehand, like our gas abstraction roundtable. So then at the roundtable, we could be like, hey, this is what we did so far. We would love more eyes on it.
Perfect.
As opposed to after, because then it's like we kind of dilute, everyone wants to get involved, and it's just like a bit sticky then. Ideally, we keep it tight, and whoever shows up from the cartel. And
so as the schedule comes out, Peter, you can set up a meeting between the
pretty much set up. I'm thinking of potentially a lunch break for a couple hours. Maybe
we can all get together. Awesome.
Might be really good. And I'll figure out a room. I'll try to figure out a venue, a room. But I'll try not to make it outside of DevCon hours. If that's cool.
I have a preview of the schedule for the DevCon if you're interested.
Oh yeah.
I do. I also have it. So can
wow.
We all have it.
What do you?
Okay, so yeah, if everyone has it, then just
like everyone else has
it.
Like I'm not part of the club, you know.
I put it in the Zoom chat if somebody's interested.
And I send the PDF on the Telegram channel, so that it's. I think the PDF is easier to.
DevCon leaked. Yeah, but cool. Cool. I'll probably. We'll figure something.
I'll summarize it all and push it to GitHub, and maybe
would be cool, actually, if it's But yeah, Marek, would you like to do that?
So yeah, where would I push the current version?
Probably just on GitHub.
Okay.
Yeah.
I'll do that. I'll do that tomorrow morning. I'm not sure if I can do it today.
Yeah, no, all good. If you can't do it, maybe, I mean, the call is recorded. We could probably delegate it to someone who hasn't watched the call. Maybe. I don't want to make it too complicated, but yeah. Sounds good.
I better get back to work. Thank you guys very much. This has been wonderful. This is a great group of people.
Thank you.
See you guys later. I look forward to that.
Bye-bye.
Bye.
Look forward to. Bye-bye.